Welcome to your third and last lesson of your summer supplement. I'm going to break it down into two parts. Our title is Solving Rational Equations and Inequalities. So the first part will be dedicated to solving rational equations, and then the second part we'll look at an example learn to solve inequalities. This session is important. It takes what you've learned about common denominators in the past two lessons and all of the equation solving skills from your previous algebra courses. So it teaches a new concept, but it's also going to be good for you to review some of the other things that you may need to bring forward into your pre-calc class. We're going to be working through a number of problems, and then you're going to practice on your own. Make sure that you check your answers, especially on these. If you'll recall, in the past, we sometimes had false right answers. These are the type of problems where you are likely to find some of those false right answers. There's a risk of zeros coming up in the denominators when you go in to try to check your answer. So it is important, first of all, that you work very carefully. Second of all, that you check your answers. Your answers are not complete until you check them. It would be very incorrect to write down an answer that would give a zero in the denominator. So you have to check your answers before you can submit a final answer as being correct. So it's even more important than these problems, not just seeing, am I right? Did I work carefully? But to check and see if one of those false correct answers has come up. Alright, so let's start taking a look at some examples. Here's our first example. And we have an equation here, which means you're going to solve for x. I did actually start the work on here. Finding least common denominator will end up being part of it. But our original problem is x plus 1 over 3 times x minus 2 equals 5x over 6 plus 1 over x minus 2. So the first thing that you need to do is find the least common denominator, and you've had lots of practice in that in the last section. You have to check all the fractions involved. 3 times x minus 2. You need an extra 2 because this one's got a 2 times 3. X minus 2 is already taken care of, so you don't have to bring in another one of those. We simplify it, and here's our least common denominator. Now here's the interesting thing about these problems. Once you've found this least common denominator, you need to multiply it times both sides of the equation. Let me say that again. Once you've found that least common denominator, you're going to multiply it times both sides of the equation. The reason you will do that is that when you begin to cancel out, you will find that all of the fractions will disappear, and you'll be left with something that you are more comfortable with solving. So let's see what happens. Multiply both sides of the equation by the least common denominator. So here's your 6 times x minus 2. Here it is again. Multiplying it times this side, multiplying it times this side. Now you have to be careful that you actually are going to distribute this times both of the terms inside. You're going to have to make sure that you distribute. If you do not distribute, you're going to find yourself canceling out where you shouldn't be canceling out and losing pieces of your work. Now, once you have distributed, then you can begin to cancel. But I can't emphasize how important it is to do this distributing step first. It is extremely, extremely important. This 6 times x minus 2 has to be multiplied times each piece. Then you can begin to cancel out. So we see that the 6 and the 3 can cancel out to a 1 and a 2. X minus 2's can cancel here. These 6's can cancel out. These x minus 2's can cancel out. So your next step, of course, is going to be to simplify that so that you don't have to look at quite so much. So we bring that down, and it looks much better. The denominators, as you'll notice, have all canceled out. 2 now is multiplied times x plus 1. We're only left with x minus 2 times 5x for this one, and we're only left for 6 here. So multiplying both sides of the equation by the least common denominator serves the purpose of making a much easier to solve problem. Now all of you know what to do from here, but since we're getting you ready for pre-calc, let's review it. We need to distribute that 5x in there. We need to distribute that 2x. So let's do that. We distribute the 2. We distribute the 5x. And we're working on our goal of solving for x. We find that we have an x squared that doesn't cancel out. So our clue is that we're going to have a quadratic equation to deal with. So what we need to do then is, remember, in any quadratic we have to have a 0 on one side. So I'm going to subtract 2x and I'm going to subtract 2 from both sides. When you do that, we'll get a negative 12x and we get a 4. Now after you have done that, the easiest thing to do for a quadratic is to try factoring. You can use the quadratic formula if you like. However, what I've found is if it is factorable, it makes a much easier problem and it makes it much easier not to make mistakes than using that quadratic formula. So let's plug this in and let's see what we can do about factoring it. If you'll recall, when this number over here is not a 1, first thing you should do is multiply this term and this coefficient and the constant term. Here it is. And then you should look for what factors of this number will have a sum of this number. And then you use that to break apart this middle term so that you can factor by grouping. So we have a negative 2x and a negative 10x. All we've done here is rewrite it. This is just your factoring review. Then we see what's in common here and what's in common here. X is in common for here, 5x minus 2. Now be careful whenever you have a minus in here, you're going to want to factor out a negative of the common factor. The common factor here is 2, so we'll factor out a negative 2. That'll give us a positive 5x in here. Negative 2 times 5x is negative 10, and negative 2 times negative 2 is positive 4. That's helpful because these two then will match each other. And as long as this part up here worked, you're expecting them to match. If they don't match, check your work and make sure you haven't made a mistake. So that means that x minus 2 times 5x minus 2 equals 0. Okay? Because 5x minus 2 was actually the common factor of x and negative 2. So that's where that comes from. Then we recall that the zero product property says that as long as you have 2 or more things that are multiplied together that give you 0, at least one of them has to be 0. So that means that either x minus 2 is 0 or 5x minus 2 is 0. Okay, now it becomes easy to get x by itself. Add 2 to both sides in both cases. This one's done, but this one needs to be divided by 5. So here's your two alleged answers. However, remember what I said a minute ago. I said it's not done. You are not finished until the answer is checked. So we're not trying to save any trees here. Obviously, these problems get into a whole lot of work. Just persevere through, though, because each individual step is not very difficult. You just have to not give up on them. So let's go back and check. Here's our two answers, and we need to check both of them. So we're going to plug them in one at a time and see what we get. Okay, here's our original problem, and we've taken that 2 and we've put it in wherever we see an x. And here's another one. And then we begin to simplify. The problem is that I'm getting zeros in a couple of the denominators. Those make undefined fractions. You can never divide by a 0. So what this means is I don't have to go any further. As soon as I get a 0 in my denominator, it tells you that this number is not a solution. So x equals 2, we did all of our work correctly, but x equals 2 is not a solution to this problem. It gives you undefined denominators in the original rational expressions, so we can't have that. So x equals 2 is a fake. Now let's check x equals 2/5. So we're going to go back and plug 2/5 into wherever these x's are. And we're trying to check to see, do these things equal each other? So take your time, plug in these numbers. We'll do some simplifying. 2/5 and 1 is 7/5. When you take the time to simplify this, we get -24/5. When we simplify this, the 5's cancel, so we get 2/6. We get 1/-8/5 here. We keep on simplifying, still trying to find out if they're equal to each other. Divided by means times the reciprocal. Now, what you'll do if you have the graphing calculator, you have a calculator that can handle it, you can probably put more steps in all at once, but be careful not to put too many in at once. It's very, very easy to make an error with fractions. You have to be super careful with your parentheses because the order of operations can really mess with you unless you have put everything into the calculator perfectly. So you might want to do it in steps like this anyway. And when we do finally solve it down, we do find out that the two answers are equal. We never got a 0 in the denominator, so that means that x equals 2/5 is the only answer because the other one turned out to be a fake. So we have one answer to that problem. X equals 2/5 is the only number that will actually solve this without giving us a mistake. All right, let's check another one. All right, now this one is a little bit more complicated as far as seeing what the common denominator is. We will have to factor a little bit here. So let's do that. We're going to find the least common denominator. So when we factor, we get 2r plus 1 has to be part of it. We need a 3. And we need an extra 2 from this fraction. The 2r plus 1 from here is already covered, so we don't need that again. We'll simplify our least common denominator. And then, as you recall, we need to multiply both sides of our equation by our least common denominator. So there it is. Multiply both sides by the least common denominator. Now, once again, as you recall, we have to distribute. It's going to save you from making a whole pile of mistakes, so we need to make sure that we do that. Here's this one, and this one, and then this one once again. And then once you have them distributed, that's when you can begin to cancel out. Okay? Make sure you're taking your time as you go through these things. Pause if you need to, so that you can get them written down. Now we can begin to cancel. 2r plus 1 cancels out. 6 and 3 cancels to a 2. 3 and 2 cancels to a 1, and the 2r plus 1 cancels out. Remember, your expectation is that if you found your least common denominator correctly, when you multiply both sides by them, that you shouldn't have any denominators left. Everything should have canceled out. So we can clean that up and simplify it a little bit. 6 times r plus 2. 2 times 2 plus 2r plus 1 and r, and 3 times 3. Then once again, you need to begin to simplify. 6r plus 12, distribute here. 2r, to r, because I moved this r over here, it'll be easier to distribute that way, times r plus 1, plus 9, that one should be obvious. Then we'll distribute that 2r, 4r squared, 2r, and 9. We need to go to the next page because this is a long problem. So all I did for the next thing is I slid this one up and gave us a little bit more room. Once again, it comes out to be a quadratic. You subtract 6r from both sides, subtract 12 from both sides, and these are the results that you get when you do that. Always check to see if it can be factored. So we want to do that. Remember, this is not a 1, so multiply them first before you're looking for the factors that give you the magic middle. So negative 12 and 1 is negative 11. That didn't work, but negative 6 and 2 gives you negative 4, and that one works. So we'll break it down into its two pieces. Negative 6r and positive 2r. Then factor by grouping. 2r is in common here. 2r minus 3. 2r times 2r gives you 4r squared. 2r times negative 3 is negative 6r. Now take a look carefully at this one. It doesn't appear that there's anything in common, but keep in mind a 1 is always in common, so we'll factor that one out too. Now 2r minus 3 is in common here, so we factor that once again. Now you have two things ready to set equal to 0. There and there. Remember, zero product property says that you have two things multiplied together, one or the other has to be equal to 0. Then the simple steps, solve them both. Subtract 1, divide by 2, add 3, divide by 2. We have two possible answers, but we know that we are not done until it's been checked. So we need to go back and begin to check these answers. So what we're going to do here is check r equals negative 1/2 first and plug it into all the places. Everywhere you see an r, put in a negative 1/2. There we go. And we begin to do the work. And we find out here we get a 0 and here we get a 0. That's a problem. Same problem that we had before. R equals -1/2 is not a solution. You cannot have zeros in your denominator. And we'll go back and we'll plug in R equals 3/2. Everywhere you have an R, you have to put in 3/2. Then we begin to simplify. 3/2 and 2, do all that math. And 7/2 over 4, 3/2 over 3. Okay, at least there's no zeros. So we can keep on going with that. Remember, this one is a complex fraction, so it's times 1/4. This one's times 1/3. A little more simplifying. Does 7/8 equal 1/2 plus 3/8? It sure does. 7/8 equals 7/8. So since they equal each other, that means that R equals 3/2 is a solution. It's our only solution. And this one is finished. So those are two examples of solving equations involving rational expressions. Again, our key important thing is to find those least common denominators. Once you've done that, you just need to show patience and effort, and then be very careful to check your solutions at the end to make sure that you haven't come up with anything that's a fake. All right. Now all we need to do in the next session in part 2 of lesson 3 is to handle what happens if we have an inequality.